In the inland areas of the Antarctic ice sheet, air temperatures are very cold, so a small amount of air temperature change will not significantly impact on the size of the ice sheet directly. This is in contrast to the Greenland ice sheet, where air temperature change is causing increased melting. In much of Antarctica, it is the indirect effects that cause big changes in the ice sheet, such as changes in ocean circulation. Ocean water around the planet varies in its temperature and salinity. This changes its density, which helps cause ocean currents to form. When the water is dense, it sinks. So these currents form at different levels in the ocean. Wind blowing across the surface of the ocean also helps to drive ocean currents. And changes in the wind can modify ocean currents that will impact on marine ice sheets. At the edges of the ice sheet and under the ice shelf, the water is very cold and fresh as it is formed from melting ice. In the deeper ocean around Antarctica, there is an ocean current called circumpolar deep water which flows around the continent. This water is a few degrees warmer than the melted ice water. So if it comes into contact with an ice shelf, it will cause much higher melting of that ice shelf. Sometimes changing weather patterns cause wind directions and speeds to change, driving the water from the deep ocean to under the ice shelf. A major impact of a warmer climate is a change in sea ice conditions. Sea ice forms a barrier between the wind and the ocean surface, damping the effect of the wind on the ocean currents. If the sea ice is reduced, the wind may have more ability to cause warmer water to flow beneath the ice shelf. While a small increase in air temperature will not have a big impact on the interior of the ice sheet, it does affect more coastal areas at lower elevations. The Antarctic Peninsula has seen some of the biggest rates of air temperature change in recent years, which has led to many ice shelves retreating and breaking up like we saw in the ice shelf video. This then affects the ice streams flowing into these ice shelves.
When we think about ice sheets and sea level, there is a difference between the floating parts, ice shelves and icebergs, which have already displaced ocean water, and the grounded parts, which haven't. Think about a glass of water with an ice cube in. When the ice cube melts, it doesn't change the level of water in the glass. But when you melt an ice cube outside the glass and put the water in the glass, the level will go up. If the entire Antarctic ice sheet was to melt, it would raise sea level by 58 meters. But much of the ice is in the larger East Antarctic ice sheet, where large parts of the beds are above sea level and very cold. So we don't expect these parts to be very vulnerable to climate change. The West Antarctic ice sheet is a largely marine ice sheet, however, so is vulnerable to increased melting from changes in ocean circulation. If the West Antarctic ice sheet were to collapse, it would raise sea level by about 3 meters. The marine parts of East Antarctica could add a further 17 meters to the sea level change. The timescale over which this would happen is uncertain, but a lot slower than in the game. It could take hundreds or thousands of years for the West Antarctic ice sheet to collapse. This would make a very boring game, but we will see the impacts of ongoing sea level change in our lifetimes.